Okay, so we are continuing our point class. We've got a point class with two constructors, getters and setters for both x and y, a translate function that moves it, and a toString method that prints a string representation of the point. We've got a client that corresponds with that stuff and tests it all. We're just continuing with our last two methods, the equals, which will return true if 2 points are equal. So what does it mean for 2 points to be equal? The 2 points are going to be equal if their x and their y coordinates are the same. So how do we write that code? We go back into here, and I'm going to put it in between translate and toString. I want toString to be last. I think that's just a personal preference, but I think it's a good one to stick by. So I'm going to go public. There's no static. There is a Boolean, because it's going to return true or false. And it's going to be equals. So, you know, we have the dot equals for strings, right? Or dot equals ignore case, etc. This is the weird thing. So it has a single parameter of a point, and what we usually do is we call it the other. So this is going to refer to the point I'm in, and other is going to refer to the point that's coming in as a parameter. So I'm going to return I'm going to say if this dot x is equal to other dot, so I can't do got x. See how it says it's red? I have to do other dot get x because it's a private field. I can't access it directly. And so I guess I don't really need the x here. I can just use x and y because they're, again, I'm not using x and y anywhere else. So I can just say if x equals other dot get x and y equals other dot get y. And I don't really need an if statement. If that's true, the two things are equal. If it's false, the two things are not equal. So that's just really my return statement. It doesn't like this outer. Oh, I just need a semicolon. Return x equals other dot get x and y equals other dot get x. What I also don't need is I don't need these parentheses if I don't want them, because it's going to do the right side. It's going to do all this statement in the return, and if they're both equal, it's going to return true. If one of them fails to be equal, it's going to return false. So we could check that back in our client. Well, we know 2 points that are not equal, and that's P and the origin. So I could say, you know, let's do a print statement. Out print. Let's print P dot equals the origin. So we know our origin was 0, 0. We set that up above here. This should return false. And it did. You know, what if I did P dot equals P? This is not a very good test because, I mean, it works. You could run into trouble if you check that something is equal to itself. You could just be referencing the name. So you want to be careful to actually check another point. So the origin worked. I could do, let's do this. Let's do new point P2, and let's set it equal to the origin. Doesn't like that. New point P2, no. We have to do a new constructor. So new point P2 equals, I'm sorry, I don't need the word new in front of it. Point P2 equals the origin. And so now P should not equal P2. We should still get false. What I'm curious is, so P is 20, negative 25. So if I take P2 and I either translate it or I use setters, so I could do P2 dot set x to be 20. And let's do P2 dot translate the y. translate. I don't want to move the x, and I want to move the y to -25. Now, P should equal P2. So we should get true there now. What I'm curious about is if P2 equals the origin, or I'm curious what has happened to the origin. So let's just print, let's print out origin dot toString. And what I'm curious about is whether or not we've changed the original point by doing this. I don't think so, but let's see what happens. Ah, we did. So notice it changed the origin. When we changed P2, so when we said P2 equals the origin, what that means is that both P2 and origin are pointing at the same place. And so when they both point to the same thing, and then we change that thing, it changes it for both of them. So that's why I wanted to be careful when I do this assignment. So we probably would have been safer here to say, you know, point P2 equals new point 0, 0. So, you know, how is this different? This actually creates a new place in the memory for P2. So even though the origin and P2 are now have the same x and y values, they are different objects. And so when I change P2, I have not changed the origin. Something to be careful of with objects, that keep in mind that the name of the object is always just pointing at the object. So if two names are pointing at the same object and we change that object, we've changed them both, sometimes unintentionally. Okay, and then the last one we'll do is distance from. And you know, to test this, probably the easiest thing is to use the point 3, 5, 3, 4. So we could look at like a 3, 4, 5 triangle from the origin. So let's change P2 to be 3 and 4. I'm thinking of a 3, 4, 5 triangle. So I'll know the answer is going to be 5 when I test the distance between P2 and the origin. Okay, so we still need to write this method distance from. So we're going to go back to our point class, and I'm going to put it above the equals. I'm going to keep equals and toString at the end, like that. And I'm going to go public. So the distance between 2 points is going to be a double. And I'm calling it distance from. And it has one parameter of a point. And again, that point is going to be the other. And, you know, it's not that complicated of a formula, but so I could just return it. But let's go ahead and just have a double here, distance equals. Let's go 0.0 for a second, and I'll just return the distance. So I don't need to have a variable inside here. I can just return the value I want, and maybe I'll do that. But first, let's come up with the formula. So the distance between 2 points, it's the square root of. So we need math.square root, and then it's x1 minus x2 squared. So it's going to be power. So math.power. Let's see, math.power. And the first value is going to be x1 minus x2. So I'm going to put in parentheses, it's x minus other dot get x. So that's the weird thing. And then that whole thing is squared, so to the second power. And then plus, so inside the square root, we're going to add. Let's see if I can hit return there. Won't let me do that. Yes, it will. No, it doesn't like that. Well, let's see what happens. Let's add the same thing, y minus other dot get y. Oh, I need the power on that, don't I? I need to put power out in front of this, math.power. And I need to put that in another set of, no, I'm going to square that. So y minus other dot get y, comma 2. So that's y2 minus y1 squared, x2 minus x1 squared, all under the square root symbol, and that should work, and then we return that distance. You know, the reason I'm setting up the variable distance there is just to make it easier to see, but I could just return all of this instead, and it might actually be less convoluted. And then I don't need that extra return in there. It's easier to see. And I still kind of like that return, and maybe just tab this over so that it's easier to see, and then I have an extra semicolon. And maybe we put a comment up here, return the distance between this point and other. So my origin is back at 0, 0. I'm going to go p2.distance from the origin. And I know that 0.334 is 5 units away from the origin. So that last thing in my client, oh, 29 is wrong. Let's see. Oh, I moved, let's see. I moved P2, so I don't want to move it anymore. I want to get rid of these statements here. So P2 is the 0.34, don't move it. It should not equal P1. The origin's still going to print. Let's run it. So that's where the testing can kind of get messed up. So the testing is working, and the distance from worked. You know, you have to usually test that with something that you would know, and this is something I knew. So that's why I set the point to be 34 and tested it from the origin. We could test it from P as well. So P is at 20, -25. I don't know. We don't know what that distance is, but you know, we could also do that. System.out. I mean, I don't have to put this in a print line. I could save this as a distance and then print it if I wanted, but I'm going to do p.distance from P2. Just test it again. It's not a very good test because I won't know if the answer is right. I mean, it should be around, let's see, from 20, -25 to 3,4. I don't know, about 30. Oh, look at that, 33. So I was pretty close. You know, maybe you'd want to print that nicely around it. I don't know. But for our client purposes, it's checked that the method worked. The point class is done. You know, and look, you know, it ends up being kind of long code, right? None of it is very complicated, but there's lots of it. So this is kind of new for us. Maybe I should go ahead and comment in here and, you know, checks if this point is equal, returns true. It's kind of obvious what it equals does, but true if the 2 points are equal. Okay, and I'll allow you a chance to pause looking at the constructors and the getters. That's the first video. Second video did the setters and the translate and this toString, which is below. And the third video did distance from and equals, one being a double, the other being a Boolean. You can pause now if you need to, and then we'll scroll down to get the toString method. The next thing you want to look at is creating I'm going to do a line object that has 2 fields, each of which is a point. And then we can maybe look at the slope and ask if 2 lines are equal or parallel, or I guess technically it's a line segment, but 2 points can determine a line. So maybe we'll think about whether we want it to be a line segment or a line. Until then, this will get us started. And I'm going to end this. And yeah.